Alright, today's topic is Unit 1-3, and this is about scientific notation. So make sure that you have your notes out and you fill them in as we go through the video. Alright, so first, learning objectives. Express numbers in scientific notation, and also we're going to do the reverse. Take scientific notation and put them in regular expanded form. Central question: when is using scientific notation the most beneficial? Alright, so what is scientific notation? Alright, so scientific notation is a way to write or express numbers that are really big or really small in a more readable, understandable way. So we keep the numbers between 1 and 10, and then we raise them to a power of 10. So for an example, when we get later on in chemistry, we'll have to use this big number right here. $602 quintillion, I believe. And you can't put this into your calculator, or if you have a calculator that you can, you don't want to sit there and write all the zeros. So you learn how to put it in scientific notation. So you can take that big number up here and write it simply as that, as a number 1 through 10 raised to a power. So that's our reason we use scientific notation, or why is it most beneficial, is because we can take a really big number, a really small number, and write it in an easier form to read. Alright, so here are the scientific notation rules. I'm not going to go through these, you can read these on your own, but these will be the steps of the rules that you would follow. Alright, but I find it sometimes trying to read all these just more complicated. Just watch. This should be review. So I want to take this big number, this 1,392,000, and write it as scientific notation. So the first thing I got to do is locate the decimal. So the decimal is going to be there. Then I have to move the decimal to where there's only one non-zero digit to the left. So I'm going to move the decimal, and I'm going to count the places. So that's 3, 4, 5, 6. So I moved it 6 places. Alright? So then I'm going to rewrite the number. To where I move the decimal, so this is going to be 1.392. Then I got to add a times 10. Now the times 10 part takes care of how I move my decimal. So I want these numbers to have the same equal value. So now, since I moved it to the left 6 places, my exponent stays positive, and I simply add a 6. So, if I move to the left, if I move my decimal to the left, I go to the left, I get a positive exponent. My exponent stays positive. Alright? So now in this case, if I look down here, I'm going to take a very small number. There's my decimal. I'm going to move it this time to the right. So when I move it to the right, I count how many places I'm moving it to. And I stop when I have one digit, in this case a 2, to the right of the decimal. And then I'm going to rewrite this one. So this would be 2.8 times 10. This case, I moved it to the right, so it's going to be negative, and if I count the places I moved it, it would be 8. So I take this really small number, and I write it in this scientific notation form. So if my number is a big number, my exponent should stay positive. If my number is a small number, my exponent should be negative. So you can kind of write that off to the side. You want big numbers have positive exponents. Small numbers have negative exponents. Alright? And you can also write this. This is the other way you can kind of help to remember. Alright? If I move the decimal to the left, alright, to the left, you have a positive exponent. If you move the decimal to the right, you have a negative exponent. Alright, so these are kind of ways to help. So let's look at this example here. Where's my decimal? Right here. So I'm gonna move it to the left. So if I'm gonna move it to the left, I'm gonna get a positive exponent. So I'm gonna count the places. So 3, 6, 9, 10, 11. So I'm gonna move it to the left 11. Now, what we have to be careful of is we got rid of these zeros up here. Alright? We got rid of these zeros up here, we got rid of these zeros. Now what happens is I have to keep all the numbers that are not zeros. So I gotta keep these zeros because I gotta keep this one. Alright, so I can get rid of these zeros. But I gotta keep these other ones. Alright, so make sure you understand that I gotta keep this one, so I gotta keep all these zeros when I write this answer. So I would get 6.850001. I keep those zeros times 10. Since the number is big and I moved it to the left, it's going to be positive 11. Alright, so same thing down here, except now I'm moving to the right. And this is a small number, so my decimal will be negative. So I count the places 1, 2, 3, 4. Alright, but I have to keep all these other numbers. Why? Because of these two ones down here. I can't get rid of these zeros. The only zeros I can get rid of are these right here. So my answer for this one would be 4.00011 times 10 to the negative 4. Alright, so now we also have to be able to do the reverse. When we say the reverse, you take a number from scientific notation and you write it out what we call the normal or expanded form. Alright, so write these in regular notation. So this is actually pretty easy as well. If I have a positive exponent, it means I'm going to move it to the right. So the number tells me how many places I move it. Since this is positive, the number is going to get bigger, so I'm going to move the decimal to the right. So 1, 2. Alright, so I moved it 2, but I got to move it 5. What happens when I run out of room? 1, 2, 3. I got to add the zeros. So in this case, I'm going to have to add 3 zeros here. So this number is simply going to be 360,000. When I run out of number information, I got to add zeros. So then if I have a negative exponent, in this case it's negative, the number's got to get smaller, so I'm going to move the decimal to the left. So I move it 5 places. If I run out of room, I got to add zeros. So I'm going to add some zeros here. So the number in this case is going to be 0.0000054. So now you do not have to put this first zero if you don't want to. You can get rid of it. But these 4 zeros have to be there. Alright, so let's look at number 3. Same thing, negative exponent, moving to the left. I'm going to move it to the left 3 places. If I run out of room, I got to add zeros. So I'm simply going to get 0.005060. Alright, this one down here, positive exponent, I'll move to the right. So once again, I'm going to run out of room, or excuse me, not room, but numbers or digits, so I got to add zeros in this case. I got to add numbers. Alright, so if I want to think of some rules or tips for these, I would add these to my notes. The positive exponent means move the decimal to the right. Number gets larger. Alright, so then in the opposite, a negative exponent means move the decimal to the left.
You think you can get your slow stuff?
So this means the number gets smaller. Alright, so there's some more examples I want you to try to do on your own. So hit pause, work out these examples, and then once you think you have the answers down, unpause and you can see the answer key. So make sure you work these on your own first. There's the answers to the first 6. Check your work. Now hit pause and see how you did. Here are the answers to the next group. Hit pause and see how you did.